Hello students, and we're basically kind of finishing up with volumes here of cylindrical shells. I'm hoping to have a quiz over this sometime next week and then kind of finishing up the course after that. If you look at this now, this is actually called cylindrical shells. As you can see over here, this is the title that MyMathLab gives, and I just put shell method over here. What you need to understand about the shell method, it's really kind of the same thing as disk and washers, but sometimes disk and washers are not the best option. If you take a look at this example here, and they're rotating around the y-axis, you would have to take top minus bottom. Well, the top and the bottom are the same equation, so that's not feasible. So you can't do a disk on this. What you should envision is going on, if you can imagine like a soda can or pop can, however you want to refer to it, and you cut off, oops, let me get back into pen style. If you cut off the top layer of a can and the bottom layer of a can, it's basically a hollow can. You should be able to kind of like look straight through that piece of can there. You just have a shell of a cylinder. It's a hollow cylinder. Now, the reason why we do this is because we can actually just put layers and layers around the shell so that it kind of fills in what we're doing. So what's going to happen over here on this piece? It's like this piece is going to be a shell. It's going to be rotating around the y-axis, and then this piece is going to be a shell. So basically, from 0 to 4, there's going to be an infinite amount of shells that are rotating. So it's basically a layer of a shell inside of a layer of a shell inside of a layer of a shell. Wow, how confusing is that? Now, let me talk about the equation and why they came up with this equation. If you actually take a cylinder, let me draw this out. If you actually take a cylinder and actually cut it at one of the sides, just cut it straight down and then unravel it, you would actually end up with this shape. It's a rectangle. Well, how do we find the length of this shape? Well, that's the circumference of it, so that would be 2 pi r. How do I find this? This would be the height. The height is always indicated by the function, though, so it's usually like the y equals or the x equals equation. And that's basically the equation right here, as you can see. So real quick, I want to kind of explain the reason why we put 2 pi x. This is 2 pi r. The r is the x value, the radius of it. So as you look at this, basically how far we move out on this section is the radius. So if I put a cylinder, I think right here at this region, that's the radius. If I put the cylinder right here at this region, that's the radius. And then the rest of this is f of x minus g of x. That's the height of the function. Wow, a lot of details there. I'm going to erase all that. And so we can kind of work on a problem and actually go through everything. Something that you should notice, though, and this is what's confusing about once we leave disk and washers and then we get into cylindrical shells. When we did disk and washers, I rotated around the y-axis. I put it with respect to y. Now, whenever I do shells, if I rotate around the y-axis, I put it with respect to x. Be careful with this. I usually write out some key notes on this, something that you should kind of take note of. Now, let's go ahead and write out the notation here. So this again is going to be with respect to x. I'm looking at this problem here. So basically what it's going to be is, since it's with respect to x, we're going to go from 0 to 4. That's the constraint. I like to always put the 2 pi on the outside just because it's a coefficient. It's not going to do anything. The x is the radius of it, the radius of our region that's going to be rotating around. Again, the radius is just going to keep on getting larger and larger and larger and larger. And then I got to represent the height of the cylinder. Well, the height of the cylinder is whatever the equation states. If I wanted to know the height at 1, let's just say this point 1, I would plug 1 into this equation, be 4 minus 1, and 4 minus 1 would be 3. And if I want to figure out the height at 2, I would just plug 2 in, and that would be 8 minus 4, and that would be 4. So the height is always just given by whatever the function is. So in this case, 4x minus x squared. Again, I'm just going to type this into my calculator. As you can probably imagine, MyMathLab does want this written in terms of pi. It's not too surprising. Let me write this out. So 0 to 4. just make sure you get all the parentheses and everything else in there correctly. 4x minus x squared, and then dx. So what I get with the integral is 64 over 3. Just don't forget the 2 pi. So this part I get 64 over 3. And if I take 2 times 64, what is that, 128? 64 times 2, yep, 128. So the final answer will just be 128 pi over 3. And that is exactly what they're looking for there. So 128 over 3, just don't forget the pi, and then check answer. And then there's your solution. I'll do one more just so we can take a look at example here. Let me scroll this up so we can kind of look at everything else. All right, so again, I'm going to use a different color. Integral is going to be with respect to x, 0 to 2. Again, I usually put 2 pi on the outside just because it's a coefficient. It's not going to do anything. X is the radius, and then I got to represent the height of the function. The height of the function is going to be the 13, 1 plus 13x squared. You can see they had a -1. The -1 just flips it and puts it on the bottom in the denominator. This red line keeps on bothering me. Looks like it's part of the equation. Just make sure I wrote everything correctly. Just type it in your calculator. That's probably the worst part about this. I'm hoping this one works out nicely. It may not. 13 over 1 plus 13x squared. And then with respect to x, calculator's thinking. Oh boy. Put the exact answer. So whenever I turned it into an exact answer, it turned into 15,369 over, make sure I say this right, 7,742. I'm just afraid that this answer is going to be incorrect here. They may expect you to go through and show all of your work. Oops, let me get the pen back here. And what I mean by show all of your work, this is 13x over 1 plus 13x squared dx. So you may have to do like a u substitution. I'm going to go ahead and put this on pause and finish up the u substitution. I'll come back and show my work. And just to kind of recap the whole u substitution, I made u the 1 plus 13x squared. Took the derivative on both sides. That ends up to be 26x. Divide that over, so whenever I substitute the dx in, dx is du over 26x. This simplifies and becomes 1/2. But when the 1/2 comes on the outside, the 2 on the outside and this 2 will cancel. So actually, I'm going to go ahead and do that. This 2 will cancel, this 2 will cancel. And you should remember the antiderivative of 1 over u, which is natural log. Now, something I want to do first of all, this was 0 to 2, if you remember that. And if you remember this, these are in terms of u, but the 0 and 2 are in terms of x. So if I plug in 0 for this equation, I get back 1. If I plug in 2 for that equation, I get back 53. And now whenever I solve it out, I get pi natural log 53 minus natural log 1. Natural log of 1 is 0, so the final answer is pi natural log 53. Even if you go through the question help, they'll go through the exact same process and procedure. If you have any other questions or concerns, definitely contact me and we'll go through everything. Thank you. Have a good day.